Alright guys, here's a second scenario that we might encounter with the ambiguous case. So I kind of mentioned this before about having two solutions. This is an example where we're going to have two different solutions for this triangle. And I apologize in advance because when I draw the second triangle, you guys know my artwork is not good. So let's get into it. Let's say I'm given these parameters, right? Well, I'm still going to solve the same way I solve any law of signs problem. So, when I solve this law of signs problem, also, before we get in too far into law of signs, we will be talking about the law of signs and the law of cosines. Both you did see in geometry. Think about why we use the law of signs. We use the law of signs whenever we have a ratio of an angle and its opposite side length. If we did not have a known angle across from a known side, that's when we use the law of cosines, which we'll cover later on in chapter 6. So, let's jump into this. I can set up my ratio. Tell you what, we'll write it in reverse this time. And if you want to follow along with the calculations, this will still give you a valid answer, having the angles on top instead of the side lengths. Doesn't matter, right? So, let's say I set up this problem. We can solve for angle B. And go ahead. I'll take a quick, I may want you guys to pause the video. I'll take a quick pause right here. Go ahead and try to solve for angle B and see what you come up with using a calculator. Now, if you did hit pause on the video and now you're playing it again, welcome back. But you would get that B is roughly 50 degrees. And again, that's rounded to the nearest degree. I think it was 49.8. Now, when we solve for angle B, recall the inverse sine function which you just used to solve for angle B will only give you an acute answer. It always will. Inverse sine will only spit out acute answers. But I don't know that this angle necessarily is acute because of the way I drew it. No, I'm just drawing a generic triangle. Angle B also could be 180 minus 50 or 130 degrees. Which one is angle B? Well, actually, in this case, angle B could be either one. I don't know that the triangle is necessarily drawn this way. I'm just drawing it based off of, hey, this is what triangles look like to me. I could have drawn this triangle as, this is where I apologize for the drawing because I'm not good at drawing triangles in this way. Good at drawing it like this. We could have set it up as an obtuse triangle. And that would have been valid as well. The reason why we can't exclude either one of these answers is, well, 50 plus 35, that's under 180, so I'm okay. I can then solve for angle C. 35 plus 130, that's 165. I still got room left over for angle C. What this situation has got me to is there are two triangles with these given conditions of angle A being 35, side A being 12, and side B being 16. Because we have two triangles, we are getting two solutions. Two solutions means two different triangles. So then I could go ahead and solve for angle C and side C in my first drawn triangle, as well as angle C and side C in my second drawn triangle. These are the two solutions, okay? Again, why are we getting two solutions? When I solve for angle B, I got 50 degrees or 130 degrees. I cannot rule out either one of these angle measurements because they both fit inside the triangle. And when I say fit, I mean if I add it up to the other angle, it's still under 180 degrees. It fits inside the angle requirements. 130 also fits with my angle requirements. Therefore, I have two solutions, and I could go ahead and solve for angle C by, in this case, 35 plus 130 is 165, so angle C has to be 15 degrees. Or I can solve for angle C up there as well. When we solve these problems, be on the lookout for one solution, two solutions, or no solutions. I'll show you a no solution problem in our next video.